All right, so in this worksheet, we're going to take the characteristics that we already know, and we're going to expand them using some of the characteristics that we already saw last semester. So really nothing is new, but I'm still going to go over it and make sure that you fully understand it. The ones that you should know how to do are axis of symmetry. So go ahead and write down the answer. You should be able to write the vertex, determine if it's maximum or minimum, x-intercept, and the y-intercept, okay? I got you. In one moment, we'll talk about interval of decrease. All right, so can you guys flip to the previous page where you have all the definitions? Okay. Oh, I have the other one. Never mind. So the axis of, my apologies. The axis of symmetry is going to be the vertical line that goes through which point? Which point? Okay, that goes through the vertex, okay? And you are correct, it happens to be 2. So the answer here is going to be x equals 2. Okay. All right, can you guys give me the coordinates of the vertex, please? So that's going to be here, and it happens at? Now, looking at this graph, right, so we see how it's opening up. That creates a minimum. It creates like a valley, low point right here. So this is a minimum. And it happens at y equals, so for that you need to go to the y-axis here, 0. Okay. When looking at this x-intercepts, how many times is this parabola crossing your x-axis? 1. So you only have 1, and it also happens to be the vertex, okay? The y-intercept happens over here, so that's going to be 0, 4. Okay. Now the domain for parabolas is going to be negative infinity to positive infinity, unless we're doing applications, and that's the last topic that we're going to do before the end of the unit, okay? Other than that, domain is negative infinity to positive infinity, all reals. The range, though, the range is going to be like this. If you have a minimum and if you have a maximum, this is how it's going to go. It's going to be y is greater than or equal to your minimum, or y is less than or equal to your maximum. Okay. You see how this is a minimum? Where does a parabola exist with respect to that minimum point? Above it or below it? Above, right? So all of these y values are going to be bigger than that minimum y value. So that's why we say that the range in this case is going to be this one. It's going to be y is greater than or equal to 0, because 0 is the minimum. We established that over here. So it kind of makes sense. The parabola is above, so it's going to be greater than or equals to, okay? It's above it. Now, intervals of increase and decrease. You need to remember that x's start at negative infinity, and they end at positive infinity. Clear? Your x's. Now, this function in particular, even though we have arrow tips here, and they're both going up, we read these graphs from left to right. So we would consider this to be a decrease. Please label your graph. And at this point right here, at the axis of symmetry, it becomes an increase. Okay. So we would say that the interval of increase starts right here at 2 and keeps going until positive infinity. We're looking at x values, people. From which x to which x? All right, so from here to here, the function is increasing. From which x value to which x value is the function decreasing? Keelan? It's decreasing from negative infinity, and it stops decreasing at 2. So yes, the axis of symmetry is the point where the parabola makes a switch from increase to decrease or decrease to increase. Right? Now for the last one, end behavior. End behavior is going to be only two types of answers. The parabola is either opening up, so the function is both ends are going to positive infinity, and if the parabola opens down, both functions are going to negative infinity. That's it. And they're always going to ask you, from on the left side, what is it doing? And on the right-hand side, what is it doing? On the left-hand side and on the right-hand side. That's the question for end behavior. So right here, as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. End behavior, both of them are going up. That's positive infinity, okay? All right, absorb. Which ones do you have a question on? All right, let's do one more example. Let's do another example, as you say. I would start with the vertex first. So go ahead and read the vertex. Oh, man. Can we come up with coordinates for this? Which x value do you guys think it is? It's not 3. 2.5, and since it's in between, you just want to do 6.5? All right. Since it's in the middle in between two integers, we'll say 2.5. This one is between 6 and 7, so we'll say 6.5, okay? All right, so we start with the vertex, 2.5, 6.5. Now the axis of symmetry is going to run down the middle at x equals 2.5. Clear? So x equals 2.5. So now you're going to think about your x-axis, right? This is 2.5 right here in the middle. This is negative infinity, and this one is positive infinity. Okay, the humming. Please stop. Okay, now you need to ask yourself from which x to which x, and we're looking at these three values. From which x to which x is the function increasing? Exactly. This is considered increasing from left to right. It's an increase. Okay. So from negative infinity to 2.5, we have an increase. Right. And from which x to which x is your function decreasing? 2.5 to positive infinity. All right, so how's interval of increase and decrease? Establish your axis of symmetry, and you can do intervals of increase and decrease, okay? Let's see. Is this a maximum or a minimum? And at which y value? 6.5. All right, so now let's do domain and range, okay? Domain, the answer is always the same. Because it's a continuous function from left to right. Now the range is going to be determined by your max or your min, in this case by your maximum, right? The y values of this function, are they above or below this maximum? Right? The function doesn't exist above that maximum. Every single point on the function is going to be below that maximum, right? So we say that y is less than or equal to the maximum because it exists below the maximum. Is that clear? Now, the end behavior of the function, what is the end behavior doing? They're both going down, we say negative infinity. So on the left, y is going to negative infinity, and on the right, y is going to positive infinity. Ooh, negative. What am I talking about? They're both going negative, right? They're both going down. My bad. The answer is always going to be positive infinity, either two positives or two negatives. No mixture, because both ends go in the same direction, okay? Oh, we still have to do x-intercepts. What are the x-intercepts? So it's going to happen here at 1, 0. And it's also going to happen here at 4, 0. What about the y-intercept? Where does this function cross the y-axis? No, not negative infinity. It's going to be a point. We just don't know where that point is, right? So it's just unknown. The point exists, but we don't know what it is because we don't have that information here on this graph. All right, would you like me to record another one of these? That's good?